Episode 5: asm.js and WebAssembly.
asm.js and WebAssembly are two web technologies used to run native code in the browser without sacrificing too much performance. JavaScript is a dynamically typed language, and languages like that are typically harder to get faster. Take, for example, a simple expression like a plus b. In statically typed languages, if you know in advance that a and b are, let's say, integers, you simply issue a single CPU instruction for adding two numbers. In dynamically typed languages, when you say a plus b, a can be anything, a number, but also an array, object, a function. And for example, according to the spec, if you add two empty arrays, what you get in return is an empty string, at least in JavaScript. asm.js was an effort to run native, statically typed languages in the browser. asm.js is not meant to be written by hand. Typically, you take an existing source code written in C, C++, Rust, and other low-level languages like that, and you translate it into asm.js. Now, asm.js is actually a subset of JavaScript, meaning that asm.js program is a valid JavaScript program. However, when compiling to asm.js, you add seemingly unimportant statements. For example, our original program a plus b, this is how it would look like in C or C++, becomes a or 0 plus b or 0. Now, adding or 0, arithmetic or 0, doesn't change the actual number. It's a no operation. However, when the JavaScript engine sees an expression like that, a or 0, it knows that it has to be a number. So in other words, we are casting arbitrary expression into a number. And when JavaScript engine sees number plus number, and it can deduce that, looking at the source code, it knows exactly how to add two numbers. This is a great performance optimization. Another performance optimization that asm.js adds is the lack of garbage collection. It's not a coincidence that I mentioned C, C++, Rust, but not Go or Java, because these are the languages that have garbage collector. Programs translated into asm.js are not supposed to produce any garbage, meaning they should allocate and deallocate memory on their own. So once again, asm.js is not another language, it's not a library, it's just a way of writing JavaScript programs in a way that's much easier to reason about for JavaScript engine and for the ahead-of-time compiler. This translation happens using a tool called mscripten that takes an existing source code and translates it into a subset of JavaScript. asm.js is kind of a hack. Therefore, there was an effort to create something a little bit more standard, which later became WebAssembly. WebAssembly is the fourth language running inside a browser, next to HTML, JavaScript, and CSS. WebAssembly is a binary language that has the same purpose as asm.js, but it's implemented in a much different way. You no longer send a stripped-down version of JavaScript. Instead, you send a binary code that's run in the JavaScript sandbox. Is this whole transformation worth it? Well, in some benchmarks, asm.js and WebAssembly are only 2 times slower than the native binary code like C or C++, which also means they are much faster than the corresponding JavaScript code. It's pretty amazing that you can now compile a full Unreal Engine or a Unity engine into asm.js or WebAssembly and run games like Quake 3 inside your browser. That's it. You're gonna find more materials under 256.nurkiewicz.com/5. Thank you so much and bye!